Hi, thanks for joining me today, where I'm going to be discussing redefining the approach to mobile security. My name is Mike Burr, and I'm an Android Enterprise Security Specialist. I work on the Android Enterprise team, and I focus mainly on security and helping customers as well as partners in the broader ecosystem in understanding Android security for better adoption into enterprise use cases. Before we get started, I want to kind of lay the groundwork for you of what we're going to be talking about. Now, obviously, Android, I think everyone knows this, Android is the largest mobile platform today. We regularly see 2.5 or actually over 2.5 billion devices checking in to Google Play services every day. Um, Coupled with all those devices is an application ecosystem, and that's Google Play. And it is the world's largest application store. It has over 2 million apps, and there's been over 90 billion installations since its inception. Before we jump into the main topics, I want to frame up kind of where we're going to start. And protecting Android devices is a difficult task because it's an open ecosystem, but we provided many ways for the ecosystem as well as enterprise customers with ways to protect their Android devices. And it all starts with hardware. We mandate to the ecosystem that they build Android devices with specific hardware components. We build the operating system and require our ecosystem partners to maintain certain levels of security within the operating system. And then we also add very robust, what I call Google security services on top of Android. We'll talk about that a little bit more as we dig in. Finally, or the last part of the management piece before we get to management is applications. Without an application store and a way to securely deploy those apps and a way to build those apps securely, the device can't be used. So in an enterprise use case, we actually allow a very robust management capability to control those applications. Now, as we dive in, and before we kind of unpack what I call mitigations and what we've done to redefine the security, I want to quickly uncover a couple of things. There's three terms that I often hear that are sometimes misunderstood: vulnerabilities, malware, and exploits. A vulnerability is really nothing more than a software flaw that is potentially exposed, where there is a possibility of it being attacked. It doesn't mean it will ever be attacked, and it doesn't mean it will ever be exposed. Malware is software, again, it's software that is designed to disrupt, damage, or gain unauthorized access to a computer system. Now remember, it's software. And then finally, an exploit. An exploit is also software, and it's designed to take advantage of a vulnerability. And in most cases, it's designed to typically do malicious things, such as install malware, right? So, one thing I want you to keep in mind is that a vulnerability does not equal an exploit. A vulnerability is a chance. And here's the key: all components here are software. Even a vulnerability in a hardware chip is really the software on that chip. So if we can protect a device and manage all avenues for software to get on that device, can't we say that we can protect it pretty strongly? I think so. Now we're going to talk about hardware mitigation. It all starts with hardware backed security. We've mandated that the ecosystem of OEMs build hardware backed security onto their Android devices for the last several years, starting with Android 8. This is the area of an Android device that executes all the cryptographic functions, and it's done in dedicated hardware. This is the foundation for which the OS is built on top of to secure every layer above. The next piece is verified boot. And verified boot is a process by which it confirms every step of the boot process by cryptographically checking itself. And what this does is it provides device integrity. The next component is something called version binding. And again, this is a way in which we can ensure keys that are created with a newer operating system can't be installed and used on an older operating system that might have an issue for an attacker to actually break into the device. Now, this basically protects user data because if a device is compromised, the data is then erased. Coupled with version binding is something called rollback prevention. This prevents the actual operating system from being rolled back to a less secure version, again, to protect user data. And it really prevents rolling back that operating system so that an attacker can do things nefarious. The other component, and coupled tightly with the hardware backed security, is something that's part of the processor on Android, and that's called the trusted execution environment. This is a component that's walled off from the application processor part of the device. And this is where things like key generation, the key importing and signing and verification services actually happen. And it's actually executed in hardware, again, separated from the user processor. This is the part that secures critical tasks separately, again, from regular user applications. And then finally, what's based on and stored in hardware are components to ensure that your secure lock screen can't be hacked. And that's done with the screen lock and PIN verification services coupled with the data encryption. And that is used to derive those encryption keys. Okay. So now that we have a couple of those hardware mitigation components out to protect the device, we're going to jump over to the operating system. And we're just going to unpack a few of them, but these are very important. The first thing to think about is Android is built on top of SE Linux, or Security Enhanced Linux. What this really does is it silos off the different components within the kernel such that if any attack happens anywhere in the kernel, it is limited to that specific domain so that exploit can't execute in other areas. And really what this does is it makes the kernel very hard so that you actually have to exploit multiple chains or chain multiple exploits to get to real user data. The second component is actually technology. This is leading technology that we've developed and asked and used best practices within the operating system. These are fancy things like ASLR, or address space layout randomization, control flow integrity, which is a kernel protection component that checks the kernel in real-time operation. And then, of course, execute-only memory, where you can't write into the memory. It can only be executed. So these are some fancy techniques that we build in to the operating system to keep it very secure. And another large part of the operating system is application sandboxing. I know we've all heard of this term before, and it is basically what we think it is, and that is isolating every application, user applications, system applications, to ensure that the data is isolated from other apps on the device. And each service or each app runs with a very specific UID, or user identifier. And that really limits exposure from one app to the other. And that really provides protection from an app reading another app's data. That's the main component there. Now, part of managing modern Android devices and part of what's built into the operating system is something called a work profile, or data separation between a work partition or work profile and a user profile. This is done in instances where an enterprise customer wishes to deploy a single device such that a user can have a personal side of the device and then a walled off protected side of the device for business use. And we use that here at Google. Now, the standards and security services that we actually implement are actually built into the operating system and layered into that based on standards that we mandate through a program called the Compatibility Definition Document. That is what CDD stands for. We prove that an OEM has built their version of Android on a particular piece of hardware, i.e. a phone or tablet, to meet and pass the CTS, which is the Certification Test Suite. Then it must pass some other tests, and in the end, it gets a certification, and it then legally is allowed, it being the OEM and carrier, to run Google mobile services on that device. That's things like Google Play, Docs, Sheets, Slides, the Chrome browser, and all the great Google services. But it's also bigger than that. It's all the Google security services that are on those devices. So the CDD really is this. It mandates and ensures standards are followed. And it's not just about compatibility. If you read the compatibility definition documents, you'll actually find that a great portion of that revolves around mandating security requirements that the OEMs must meet. The second part is the Android Security Rewards Program. And what that does is it incentivizes the main researchers, and in that fact, any researcher that views the Android open source and then suggests fixes to problems. And that is a part of our research community. As we move into the services, there's something called safe browsing, which we've always had. That's mainly a component in Chrome, in other operating systems, but on Android, it's much more. It really provides a safe browsing experience, but it also encompasses something called WebView, which is how applications expose web data in Android applications. And what that really does is it gives you complete web protection, not only from a browser, but from building applications as well. And another great service is a service wrapped up in something called SafetyNet. There's a bunch of services in there. A main one that I'll cover here in a few minutes is something called SafetyNet Attestation. And that's a free service from Google that is available to all devices, specifically for detecting device integrity. And that's really what SafetyNet does, is it provides signals to your management provider and to yourself to know that your fleet of Android devices have not been compromised. And then finally, we have Google Play Protect. This is a built-in on-device threat detection service that is backed by machine learning. It's on all these Android devices and it's running all the time. And we'll unpack that one a little bit later. But this is our anti-malware service, basically, that's on all Android devices. Now, one of the ways that we combat application risk, now that we've learned about the hardware and what's in the operating system and how we mitigate a lot of those threat vectors, let's talk a little bit more about the application area. So we do that with three main areas: policy, education, and technology. Policy is just the fact that we mandate that when developers build applications, they have to do things a very specific way. Otherwise, it won't run, and we'll catch them either in the cloud when they upload the app for deployment in Google Play, or Google Play Protect will find the application when it is sideloaded in a non-enterprise environment even. Education is where we really made a huge investment in educating the developer community with blog videos and developer advocate programs. And then finally, with technology. We all know that the main way for applications legally, that is, to get onto Android and for enterprise customers is through Google Play services and Google Play. And we've restricted many things on those devices. And just to kind of couple that with what I said earlier, in order to deploy applications in Google Play, starting in August of 2019, last year, all new apps were required to only target API level 28 and higher. That's Android 9 and higher. So if you're a developer and you deploy an application today, it must target Android 9 and higher. It can no longer target APIs that were only found in Android 8 and below. This is how we hardened up what the applications can do and which applications are actually deployable from managed Google Play and Google Play for the consumer world. And then again, in November, we tightened it up even more, and we required all apps that were currently in Google Play to have to be updated to where they could support API level 28 or higher. Again, hardening the APIs that are used for applications that were currently deployed in Google Play. Now, one of the benefits there is we removed many old applications that were abandoned over the years and thus cleaned up a lot of those older applications. Now, the on-device component, and I mentioned this earlier, is Google Play Protect. This is the world's most widely deployed mobile threat detection service today. It provides application analysis, visibility, and control for our EMM partners. You heard me right. EMMs have capabilities to verify apps APIs to control certain aspects of Google Play Protect. It is actually, it's on all those 2.5 billion devices I mentioned. And here's the kind of cool thing, is it actually scans over 1 billion apps every single day on device. So that's a great signal to you that it is widely deployed and it is pretty powerful. It runs in real time. It detects apps 24/7, and it scans all apps every single day, even apps in the system partition that are deployed by a carrier through an over-the-air update. Now, what's on the device is super important, but also what's in the cloud. Starting last year, Google started working with 3 external ecosystem security vendors, namely ESET, Lookout, and Zimperium, to build something called the App Defense Alliance. This is a program that Google built with these 3 other vendors, and it was created to ensure the safety of the Google Play Store. And together with the partners, we really aimed to find and strengthen all applications and prevent potentially harmful apps from getting on user devices. So this is a service that is just part of Google Play now and protects apps in a holistic way. Now that we've talked about the hardware, the operating system, and applications, and a little bit about how we scan and protect those apps, let's talk about data going to and from an Android device. And that's with network security. We've always led the pack with implementing and requiring our ecosystem partners to take advantage of the latest and greatest and best in class protection for data in transit. That encompasses TLS 1.3, which is the most current standard, and on Android 10. And you can see some of the benefits there is that it's faster, it's more secure, and it disallows certificates that are signed with weaker SHA-1 hashes. And it also ensures that DNS over TLS takes place so that query leaks, which are a common threat detect or threat vector, are mitigated. And on the VPN side, we've gotten very robust. Because VPN services on Android are at the application layer, we can do a lot of things with them. And we give EMM partners many different ways to control those, as you can see here, namely proxies within the VPN. You can prevent a user from disabling a VPN. You can force particular apps to use the VPN and not others. You can force a work deployed device to always have the VPN on. So there's a lot of robust capabilities here for you to manage on those devices. Now let's jump into something that is all encompassing here, and that is the security update story for Android. Over the past several years, we've done a lot of things to actually upgrade and make security updates much easier, regular, and consistent. And that is, we deploy and we put out a security update every 30 days, at which point the ecosystem now updates their devices much faster. We've also implemented in Android 10 manual capabilities such that you can update directly from your EMM server versus waiting for your carriers to do an OTA update. And one of the new things that we did this year for Android 10 was we implemented something called Google Play System Updates. That is a component that we can now actually upgrade directly from Google Play services outside of the normal over-the-air operating mechanism that we must wait for carriers to do. And those are mainly the areas you see here that typically have been attacked over the past 2 or 3 years. The media codecs, example given like stage fright, and some of the other things that we typically had to wait 30 to 60 days to get an update out through the carriers and the OEMs. We now can actually deliver updates to these components directly from Google whenever we need to. And again, this is information from the Android security website, particularly the transparency report section, where you can actually go and look at all these different statistics. And the one I'm calling out here is that there's almost 1,000 flagship devices today that are getting updates very quickly. So the work that we've been doing is actually proving beneficial. Okay, now that we've learned about the great hardware that's built in and the software and the applications and how we've secured all that, how do we manage it? And that's with a program called Android Enterprise. And we've taken security to a level where we can control all these features when you deploy Android devices. So that makes it very useful for many use cases. Android Enterprise has a very diverse set of devices. So it really offers the world's broadest mobility hardware ecosystem. Many different devices, many different form factors, many different prices for specific use cases. So we've made a program that actually makes it simple for you to actually confidently select, deploy, and manage those devices. And that's with the Android Enterprise Recommended Program, not only for devices, but for other partners as well, such as our EMM providers. It really gives you a way to look and see in a system that you can select devices and partners that you know you can have confidence that the deployments are going to be done in a consistent way, as well as all the devices that are in this program have mandates to be recommended for updating on specific enterprise-grade life cycles, and that is within 90 days. So that's a way that you can actually select your programs and have confidence and consistency in your deployments and ensure that your devices and programs are going to be maintained and up to date. Now, We mentioned that security is at the hardware operating system layer and the application layer. So we really want to bundle security around management and app distribution. And the way we do that is with very consistent, powerful, and flexible management capabilities and being able to privately deploy applications you build, as well as deploy public apps from the public Google Play, all wrapped around a very comprehensive multi-layer platform security architecture. So let's dig into that. The main concept around deploying Android devices in modern days is with Android Enterprise components. It has many modes of management, which we'll cover very quickly. It has very strong data separation, I mentioned earlier, to separate personal information from work information. And it has 80 plus management settings in security alone to protect personal information and work information in many use cases. Now, the flexible device management options here are listed are BYOD, personally enabled devices that have a full management, some call that COPE or COMP, corporate owned managed profile, and then work only devices, and then even dedicated devices, something that may be a kiosk type device that has a single application. And remember, moving from left to right, you get more control. And the two options on the left have that data separation where you can have a personal part of the phone and a work part of the phone that are very securely separated. Now, with the application component, we all know about Google Play, but when you deploy Android devices in an enterprise use case, we have something called Managed Google Play, which is essentially a Google Play Store for you. And it is bound to your domain, and it allows you to securely distribute your private apps separated from the main public Google Play. You can host and publish your own internal apps and deploy those directly to devices with very granular capabilities. You can also manage and configure those apps as they get installed so they're right on time and ready for the user to use when they launch it the first time. There's nothing the users have to do. This is the remote configuration, something we call managed configurations. Now, some of the benefits to manage Google Play, as you can see here, and for those that know about sideloading, I'll sum up this slide. You can prevent all sideloading. Remember back to my anti-malware and anti or threat detection component areas. Remember, the way to exploit an Android device is to get malware or a vulnerability exploited by an exploit. Remember, that's all software. So if I can control very strongly through the network and through deploying applications in a very strict way, I can very finely control how those applications get on the device. I can prevent most avenues from a piece of malware getting onto a managed device. And by the way, the Managed Google Play Store is also ISO 27001 certified, and it also has SOC 2 and SOC 3 reports if you need them. The other thing that I mentioned earlier in the safety net component was safety net attestation. This is an integrity checking tool that Google provides, and our EMM partners use this. It's a great free tool that Google uses to detect whether your device has been compromised. It's a very simple checks and balances system that's cryptographically signed, where the Play services on the device actually creates an attestation signature and sends key signals about the device to Google, and Google basically passes or fails that device. So this is great for root detection and to see if the system partition has been compromised. And EMMs can then use those attestation APIs with compliance capabilities to block and remove work data from a compromised device. Now, let's jump into the last part of this. It's the ecosystem validation. So a couple of tidbits of insight from our ecosystem that prove what we have built over the last few years is actually working, and that we have really redefined how we've built mobile security, specifically for Android. And one of those is the Gartner reports. Now, you can download the full report directly from Gartner's website. But what this report shows is that even way back to Android 8 and 9, Android really achieved the highest ratings with 26 out of the 30 rated categories as strong. So you can see in this chart here that Android and the teams that have built the operating system and the teams that have mandated all those requirements in those compatibility definition documents has in fact worked, even though we have an open operating system. This is working. Okay, now that we've covered all the aspects around security, hardware, software, applications, management, and all the great Google services that we put on the device to help you secure it, the innovation that we've driven into the operating system and the ecosystem to keep the operating system secure and to mandate best in class capabilities for securing those devices. We've built programs so that you can confidently select from a diverse set of devices and ecosystem partners on a global scale. We've given you many, many tools so that you can confidently deploy and manage those devices, regardless of what device manufacturer you have. The management capabilities in modern Android under Android Enterprise are on all devices that are GMS certified or have Google Mobile Services. So that standardized that management. And then we've given you ways to deploy apps very securely. We've given tools to developers to build those apps very securely. And then finally, we've really driven the ecosystem to build mobile security as a guidance practice for everything they do. So we do feel that over the last few years, um, building these components into Android, the services, and driving the ecosystem to do the same, that we have, in fact, redefined the approach that we've taken to mobile security on Android. Thanks again for listening. I hope you learned. Thank you.